So now we are going to explore key concepts in network security and management that are critical for understanding how modern networks operate and stay secure. Let's begin with a look at network segmentation, or VLAN. Network segmentation, also known as network zoning, is the act of partitioning a network into segments. This is done to create security zones. A security zone is a network segment of specific security requirements. A layer 3 device, such as a firewall, is used to separate these security zones. For example, a security zone can be defined for a company's internal network, and that internal network can be separated from the internet by a firewall. The network resources within a security zone share the same trust level. There are three commonly deployed security zones. 1. A trusted zone, also known as a private zone, is a security zone that contains protected network resources that should only be accessible by an authorized user or system. This zone has the highest trust level, and a network resource in a trusted zone has a private IP address and is unreachable from outside the zone. An example of a trusted zone is a local area network, or LAN. An untrusted zone, also called a public zone, is a security zone that is outside an organization's control and has the lowest trust level, with the internet being an example. A demilitarized zone, or DMZ, also known as a screened subnet, is a security zone that lies between a trusted and untrusted zone. It protects an organization's private network in a trusted zone from untrusted traffic, having a higher trust level than an untrusted zone, but lower trust level than a trusted zone. Common examples of device placed in a DMZ include a web server, an email server, or a DNS server. And third, a jump server, which is used to manage network elements across different security zones. A jump server, also referred to as a jump box or jump host, is a minimally configured server located in a security zone that is used for managing the hosts within that zone. It serves as a bridge between two different but controlled security zones and is commonly accessed from a host in a different security zone through SSH or remote desktop, also known as RDP. For instance, an administrator in a trusted zone might use a jump server in a DMZ to manage the servers located in the DMZ. A firewall is the network device used to separate security zones. A jump box or jump server, on the other hand, is the device used to manage servers within a security zone. An organization's web server is typically located in the DMZ, so it can be monitored and protected from malicious users in an untrusted zone, and protected from network resources located in the trusted zone. This has the highest trust level among the zones. A network can be divided into physical or logical segments. Physical segmentation is enabled by network devices such as routers and switches, which partition the network into isolated segments using the separated hardware systems and ensuring physical isolation between segments. Logical segmentation is implemented through virtual local area networks, or VLANs. A virtual local area network is a broadcast domain segmented at the data link layer, enabling multiple logical networks to coexist on a single physical network infrastructure. VLANs assigned hosts to specific network segments based on various criteria. A port-based VLAN, also called an interface-based ELN or static VLN, is one where a host is connected to a specific switch port assigned to a VLN. A protocol-based VLN uses protocol types to assign a host to a VLN. A MAC-based VLN uses a host's MAC address to assign the host to a VLN. VLANs improve network performance and efficiency by restricting broadcast domains and reducing network latency. The network device used to partition a network into physical segments is called a router. This connects two or more networks or subnetworks. A port-based VLN uses switch ports for assigning a host to a VLN. A protocol-based VLN may use IP header information, which is part of a protocol, to assign a host VLN. A MAC-based VLN uses a host's hardware characteristic, specifically its MAC address, for assignment. Now let's look at the concept of zero trust. Traditionally, perimeter securities operate by trusting internal network users and devices while blocking external threats, but this has become insufficient due to the rise of remote work and increased reliance on cloud-based services. Now, zero trust is a security framework that enforces continuous authentication, authorization, and security configuration validation for all users and devices, regardless of their proximity to the network perimeter. It aims to prevent unauthorized access to protected resources by assuming the existence of internal threats. For example, accessing an internal email server requires authentication and authorization for all requests, whether the requesting device is inside or outside the company network perimeter. A zero trust network follows the principles of the zero trust framework by assuming the network is compromised. External and internal threats exist on the network. Device location is not sufficient for deciding trust. Every device, user, or network flow is authenticated and authorized, and that policies must be dynamic and derived from several data resources. In comparison, traditional perimeter security provides protection from external threats by creating a trusted zone within a guarded perimeter. In a zero-trust network, trust is determined by device, user, and application contexts. It is not determined by device IP address or location. Zero Trust uses contextual information such as time of day, user role, and device history to determine trust level. A zero trust network may use this trust level to decide how often to prompt a user to re-authenticate, meaning a higher trust level can also lead to a better user experience. By eliminating the idea of a trusted zone, zero trust prevents lateral movement, an effective attack technique against perimeter security, because all devices within a trusted zone are granted the same level of trust. This allows an attacker who gains access to one device to compromise others within that same zone. A zero trust network requires authentication and authorization for all network traffic, not just incoming or outgoing traffic. Traditional perimeter networks focus on controlling incoming network traffic, so if an attacker breaches the perimeter and compromises a device, that device can establish a connection back to the attacker while avoiding perimeter security. In contrast, zero trust requires authentication and authorization for all network traffic because devices are not trusted based on location. A zero-trust network includes a control plane and a data plane. The control plane is responsible for managing authentication, authorization, and policy enforcement for network access. It includes a policy engine, which is the component that determines the application of policy for each request. It also includes a trust engine, which scores device and user trust. It contains data stores, which are components that store authentication data for the requesting device and user, and a policy administrator. The policy administrator administers policy decisions, establishing or blocking connections to protected resources. The data plane is responsible for enforcing security policies and controlling data access within the network. It includes devices and users, which are the components requesting access to protected resources, and policy reinforcement points, or PEPs, which enforce policy decisions and protect resources that represent assets secured by policy enforcement. In zero trust authorization, fine-grained dynamic policies control access based on resource and user device trust scores. Applying policy against multiple data sources allows for granular authentication decisions, improving the network's overall security and user experience. For example, a login from an employee's new laptop prompts additional authentication for accessing a sensitive database, while allowing access to the employee's calendar. All access is granted on a temporary basis, requiring users and devices to undergo regular reauthorization. Changes in a user's or device's trust score may result in connection blocking or necessitate additional authentication. A user's trust score would be reduced by multiple failed login attempts, which may indicate an attack rather than accessing resources during work hours or logins on multiple devices on the same network. A zero trust network protects against unknown threats by incorporating threat intelligence into policy decisions. Through calculating trust scores using multiple factors and preventing malware-infected devices from accessing protected resources, incorporating multiple factors into trust score calculations allows the network to recognize a potential threat from the combination of those factors. Mature zero trust networks use machine learning to drive a scoring function by analyzing known trusted or untrusted entities. The use of fine-grained policies based on multiple factors supports the implementation of the principle of least privilege, allowing access to be highly controlled and limited to only necessary access rather than just micro-segmentation or multi-factor authentication, MFA. An air-gapped network physically isolates a network segment from the internet and all other unsecured networks. This prevents unauthorized access through wired or wireless connections. The physical connection or physical isolation is commonly used in high-security environments such as military facilities and critical infrastructure systems. This is where sensitive data protection is most vital. The security provided by air gapping is highly effective at preventing data breaches and requires physical presence and manual intervention for the transfer of data. Now let's look at firewalls. A firewall is a network device or software program that controls inbound and outbound traffic based on a set of rules. A firewall rule can be general or specific. For example, a general rule may allow inbound and outbound HTTP traffic on port 80, whereas a specific rule may block inbound traffic from IP address 192.168.74.12 on port 22. A firewall is used to separate two security zones, such as separating an organization's trusted internal network from an untrusted network like the internet. A firewall can be implemented in hardware or software applications. A hardware firewall, also known as an appliance firewall, is implemented in a physical device with a dedicated processor, memory, and operating system. It offers fast response times and the ability to handle high traffic loads. A software firewall is implemented in software and runs on general-purpose computer, typically costing less and being slower than a hardware firewall. Both hardware and software firewalls must handle unexpected situations like system crashes or software failures. In a fail-open configuration, traffic flows freely if the firewall fails. This ensures that uninterrupted access to critical network services while potentially exposing the network to security threats during downtime. In a fail-closed environment and configuration, all traffic is blocked when the firewall fails. This enhances security by preventing an unauthorized access during such periods but risking, at the same time, disruption of legitimate network activity. An open source firewall is a software firewall with freely available source code that can be modified and redistributed. A proprietary firewall is built by an entity with exclusive rights to it, like the Cisco Adaptive Security Appliance or ASA series, which are proprietary hardware firewalls. Here are some things to remember. A firewall can block inbound network traffic based on a set of rules. A software firewall can be used to separate two security zones just like a hardware firewall. An appliance firewall or hardware firewall has a dedicated operating system along a processor and memory. A software firewall is typically slower than a hardware firewall due to the latter's dedication for resources. When we talk about an open source firewall, we are talking about one that can be modified because it is developed and maintained by a community of developers. A stateless firewall, also known as a packet filter, allows or blocks a packet based on the information in the packet header. It includes source and destination IP addresses, port numbers, and protocol type. It inspects a packet independently from other packets and does not track traffic flows to decide which type of traffic should be allowed or blocked. An ACL is a list of rules used by a firewall to control inbound and outbound network traffic. For example, a stateless firewall may block packets with destination IP address or allow packets with source IP address. A stateful firewall, also called a dynamic packet firewall, monitors and tracks active network connection sessions. It blocks a packet that does not belong to an active session, continuously analyzing the state or context of traffic on the network. It stores the connection session's information in a state table and uses this information to make packet filtering decisions. A network security appliance, or hardware firewall, combines the functionality of several devices to improve network security and simplify their management. A unified threat management, or UTM system, is a security appliance that provides multiple security functions at a single point on a network. This includes network firewalling, intrusion detection and prevention, malware detection and removal, DDoS protection, and web content and email filtering. A UTM simplifies security management by enabling an administrator to manage a wide range of security functions from a single console. A next-generation firewall, or NGFW, combines the functionality of packet filtering firewall with other technologies to detect and block network attacks. This enforces security policies at application port and protocol levels. An NGFW may have the capability to inspect encrypted traffic or detect and block malware or perform deep packet inspection, which enables it to inspect the data within a packet and identify and block the malicious packet. It may also act on real-time information provided by threat intelligence services to block new threats. A UTM improves network security and simplifies device management, and an NGFW can detect and block malware but not remove it from the network. Network Access Control, or NAC, is a security mechanism that manages access to a network by authenticating users and devices while enforcing access policies and ensuring that devices comply with security standards. NAC can be implemented as a standalone solution or as a feature of an add-on to a firewall, which leverages the firewall's existing infrastructure and policies. This makes it an effective tool for enforcing network security. Now let's look at host-based, virtual, and application firewalls. A firewall can monitor and filter inbound and outbound network traffic on virtual machines, and a virtual firewall is a software or hardware firewall that provides packet filtering within virtualized environments and can operate in two modes. Firstly, bridge mode is a virtual firewall in which a firewall runs on a virtual machine and monitors and controls inbound and outbound traffic on that virtual machine. Then hypervisor mode is a virtual firewall mode in which a firewall resides in a host's hypervisor kernel and monitors and controls inbound and outbound traffic on the virtual machines running on the host. A host-based firewall is a software firewall that runs on the host and controls the host's inbound and outbound network traffic. Most modern operating systems include a host-based firewall. For example, Windows Defender Firewall in Windows 10 is a host-based firewall. A host-based firewall can have application-specific security rules such as permitting inbound traffic to one application on port 40 while blocking inbound traffic to another application on the same port. A firewall may also filter web resources, which is critical for protecting organizational resources from potential threats. There are three web filtering methods. 1. DNS filtering blocks access to specific web pages by preventing the resolution of DNS queries for blocked domains. For example, an organization adds YouTube to the DNS filters block list, so when an employee tries to access it, the DNS refuses to resolve the IP address. 2. URL filtering blocks access to a specific web page based on its URL. For instance, if an organization allows employees to view work-related online videos but adds all other online URLs to the URL filters block list. And 3. Content filtering. This controls access to web content based on the requested content and predefined criteria. For example, if an employee visits a web page with an embedded video, the organization's content filter blocks the video content while allowing the rest of the web page to load. To simplify web filter management, block rules can automatically block content without adding each URL or domain to the block list. In this way, web pages are analyzed and categorized so that a block rule can block all content in a given category. For instance, an organization's web filters can configure to block social networking sites, automatically blocking social media without explicitly adding it to the block list. A web filter can also allow or block a web page based on the URL's reputation as trustworthy or risky. A website with a history of stealing personal information or spreading malware is marked as risky, while a well-known website without suspicious activity is considered trustworthy. Now let's look at network intrusion detection and prevention systems, or NIDS or NIPS. An intrusion detection system, or IDS, is a device or software application that uses sensors to detect malicious activity or security policy violations in a system. There are two types of IDSs. A network intrusion detection system, or NIDS, detects threats to the network using sensors, collectors, and aggregators to monitor and analyze network traffic for malicious activity. A host-based intrusion detected system, or HIDS, detects threats to a host by monitoring and analyzing the host's running processes, network traffic to and from the host. It also examines the host's log files. For instance, a security information management system, or SIM, system running on hosts is an IDS. A network intrusion prevention system, or NIPS, is a type of NIDS that blocks threats to a network. It is capable of taking autonomous actions to secure it, such as shutting down a network service under attack or disconnecting a suspicious network connection. In different scenarios, a device that can block an attack on a LAN is a network intrusion prevention system, or an NIPS. A software application installed on a server that can detect an attack on a WAN is a network intrusion detection system, or NIDS. An NIDS or NIPS can be deployed in two modes. Firstly, inline mode or in-band mode is a deployment mode where network traffic passes through the NIDS or NIPS, and it's deployed at a network edge where the inline NIPS can block a network attack. Passive mode or out-of-band mode is a deployment mode where an NIDS or NIPS receives a copy of a network traffic via a data monitoring port like a switched port analyzer. A test access port, a passive NIPS cannot block a network access attack. An anomaly-based IDS may generate a large number of false alarms due to flagging legitimate but new network activity. A signature-based IDS maintains a database of attack patterns to detect matches. Behavior-based detection searches for specific patterns matching threat behavior, considering abnormal process actions as potential threats. For example, a behavior-based IDS detects a process scanning multiple ports. It then flags it as a threat because that is a behavior associated with malicious processes. Heuristic-based detection uses adaptive techniques, starting with an attack signature database like signature-based IDS, but dynamically modifying signatures based on learned real-time network traffic behavior. This enables it to detect previously unknown attacks. A behavior-based IDS may flag a valid application operation matching a threat behavior. A heuristic-based IDS modifies attack signatures. Now let's look at virtual private networks, or VPNs. An organization needs to maintain control over its private network for security and privacy, and a VPN allows this even when devices are in different locations. This provides the benefits of a private network while data is exchanged over the internet. A virtual private network, or VPN, is a service using encryption to connect devices over a public network, enabling a private connection between two or more devices across a public network like the internet. There are two types of VPNs. A site-to-site VPN, also known as a router-to-router VPN, connects two or more networks used to link different locations of the same organization. For example, connecting a bank branch office to the main office or headquarters. A client-to-site VPN, or remote access VPN, connects a client computer to a remote router with software installed on the client, making it possible. For instance, a company employee working from home connects to the company network using a client-to-site VPN. A VPN is a tunneling protocol, favored for its ease of use over other tunneling solutions. There are two tunneling mode types. A full tunnel routes and encrypts all network traffic through the VPN, regardless of where the service is hosted. It is generally recommended as more secure because all traffic is encrypted, making it the better option for confidential data. Split tunneling may be necessary for simultaneous access to internet and office resources, but it is less secure. A split tunnel routes and encrypts all non-internet network traffic over the VPN, with traffic to various internet sites bypassing the VPN server. Split tunneling routes some device or app traffic through an encrypted VPN tunnel, while other devices or apps access the internet directly. This protects confidential data without losing local network access. Split tunnel mode allows a client to have both private and public connections, balancing performance and security needs. Looking at port security, a port on a network device should be secured to prevent unauthorized network access. It is applicable to devices like switches, firewalls, and routers. Port security methods include port disablement, where a port is disabled to prevent connections. For example, disabling a switch port linked to an unused RJ45 wall socket stops a laptop from connecting via that socket. MAC filtering doesn't fully protect unauthorized access because a MAC address can be spoofed using software to mimic an unauthorized device's address. Load balancing distributes network or application traffic across multiple servers in a group. It uses a hardware device or software program operating at layer 4 or 7 of the OSI network model. This increases capacity, reliability, availability, and performance. For example, a web server load balancer distributes web traffic across multiple web servers. It provides an interface via a virtual IP address and a port number.